from a disk of radius r and mass m, a circular hole of diameter r whose rim passes through the center is cut. Okay, for this particular statement, we'll see the diagram here. See, this is the diagram here. So, this is the here rim r is there and the radius is r. And the mass of this one, it is m. And whose rim is passing through the center of this cut here. Fine, this is, if this is r, then this radius it is r by 2. What is the moment of inertia of the remaining part of the disk about the perpendicular axis through the center? What is this remaining portion made to momentum inertia we need to find here? Passing through the two center here. Okay. So here, the moment of inertia of I of the total disk we can write it as mr square divided by 2. Fine. Then the mass of the removed part, that is equal to m by 4. M by 4 part, that is we remove here. Then the moment of inertia of removed part about the same perpendicular axis. This perpendicular axis, this removed part, moment of inertia is, that is we can write it as I moment of inertia I removed, which is equal to, that is m by 4 times this r is nothing but that is r by 2. Now this r is nothing but r by 2 divided by 2 whole square. We can write this one as m by 4 times r. This denominator 2 will come here, then this becomes 4. I can write this one as r by 2 whole square. Then this becomes 3mr squared divided by 32. 3mr squared divided by 32. Then moment of inertia of the remaining part of this about perpendicular axis passing through the center. That is what exactly we need to find here. That one. That is, we know that is I remaining disk. I remaining disk is equal to I total disk minus I removed part. Then we can find this one as mr square divided by 2 minus 3mr square divided by 32. We get the answer by simplifying, that is 13 by 32 mr square. By simplifying, we get the answer this one. Then we can see this option, that is 13 mr square divided by 32. Option B is our right answer.